We will now talk about various features that show in XPS. An X-ray photoelectron spectrum is generally recorded as two types of regions. When we record a broad range of binding energies with relatively larger step size, we call it survey scan. The survey scan helps us to identify all the elements and peaks and helps to identify if any impurities are present there. Okay. Now, if you look at this survey scan of titania, you notice that many core levels are present, like 2s, 3s, 3p, 2p, and among them 2p gives the maximum intensity. The higher photoionization cross section of a particular orbital is actually responsible for the higher peak intensity of any orbital, okay, than the other orbitals. So you can read about photoionization cross section more from the reading materials. And the smaller region scan, which is particular for particular core level, are recorded with a relatively smaller step size, and they are known as the high resolution scan. Okay. So a spectrum may contain various peaks like photoemission features with single peak, photoemission signals of multiplet peaks, satellites, Auger peaks, and plasmon peaks. These are very important features. S orbitals generally appear as a single photoemission peak and are designated as principal quantum number followed by the letter small s. So for a peak from 1s orbital is denoted as 1s, from 2s orbital is 2s, and so on. P, D and F orbitals produce multiplets due to spin-orbit coupling. You will notice that these orbitals give two peaks. The notations of these multiplets are based on LS coupling or J values, and the area ratios of two multiplets are also based on their J values. So the P region will have P 3 by 2 and P half peak. The D orbital will have D 5 by 2 and D 3 by 2 peaks. Similarly, the F orbital will have F 7 by 2 and F 5 by 2 peaks. Next comes satellite peaks. They are very important features for many photoemission signals. Satellites appear due to interaction of photoelectrons with changed effective charge. There are mainly two types of satellite peaks, shake-up satellites and shake-off satellites. The outgoing electron, when it interacts with a valence electron and excites the valence electron, shakes it up, we call, and to a higher energy level, as a consequence, the energy of the core electron is reduced and a satellite structure appears at a higher value of the binding energy scale or lower value of the kinetic energy scale. If the valence electron is ejected completely to the continuum, it appears as a broadening of the core level peak and contribute to the inelastic background. We call it shake-off satellite. Another important types of feature that appears in Auger are called Auger peaks. So Auger peaks are resulting from a secondary process photoemission. With an excited electron from higher core levels go through radiative decay, the resulting radiation may knock out another electron from the atom, and the process is known as Auger process. Auger peaks and Auger parameters are sometimes supplementary and very essential to identify an oxidation state of a particular element, for case copper. And for certain peaks, we also get weak plasmon peaks in clean surfaces, like for silicon 2s. The photoemission peaks appear when the outgoing photoelectron interacts with the free electron gas, or we call the surface plasmons and bulk plasmons as well. Okay, so these are the important features that we see in a typical X-ray photoelectron spectrum. Okay, with this we will move to the next topic, that is topic 4 in the next session. Thank you very much.